Hello, math fans. Going to do part one of this March Madness math series. Here I'm going to talk about just some counting tools, but enough that we can make sense of some of the numbers. If you search online for like what's the chances that you can get a perfect draw. So a few things to discuss. I did forget to have Kelsey Plum in the background, so there's my little shout out to somebody who has played and been very successful at NCAA tournament levels and competitions. Okay, so a little bit about counting. So I've set up a little tournament here between and I might add more in a second, between the Hawks, the Pirates, the Minions, and the Loggers. I was a Logger. That was the name of my college mascot. My wife was a Pirate. My daughter is a Hawk. And my son goes to a different high school, but I didn't put his high school because I thought we needed to put the Minions because we always have coached teams. My son coaches a team called the Minions, so we have to have Minions. They're the 1 seed. Okay, so we've got this little tournament. If we want to start counting different things, there's this idea of multiplying. All right, so how many possible draws are there? And this is what we call independent events. You have this game doesn't affect the other game, probably, unless someone can somehow influence one from the other. I don't know. But anyways, if you think about what can happen, this is the finals here. We're trying to gear up for the finals for someone that hasn't really thought about tournaments before. I grew up playing tennis tournaments, playing lots of sports, making tournaments. So I like to think in terms of tournaments. I love to see a bracket. But there's two people that can win this first game, the Minions or the Loggers. There's two people that can win this game, the Pirates or the Hawks. That means there's actually 4 possibilities for the final. It's the product of those two numbers. And we'll take this and extend it a little more. And then there's 2 ways you can win the last one. So often the right way to think about it in my mind is to think, what are the chances for each one? We have 3 games we're talking about here. The 2 semifinals and the final. So we have a final and 2 semis. And I would like to multiply their probabilities. Now in this case, if I'm counting, I'm just going to multiply what can happen. So there's 2 of these, there's 2 of these, there's 2 of these. There's 8 possibilities. If that's foreign to you, I know I'm starting kind of basic here, but I wanted to provide this space for this. You can fast forward and skip to the next video. But I would encourage you to list them all. Minions, Pirates, and then Minions win. Minions, Pirates, and then Pirates win. You can make a little tree of them, but you always get this multiplying effect. So this is 2 to the 3rd. Okay, so if we added some more games down here, I don't know, we'll just put college names, UW, WSU, I don't know, UCLA. Who else should we have? Oregon? Nah. I didn't mean to make any sort of political statements. We're going to put USC there. How many possible draws are there now? So what I'm saying are draws, different ways you could fill it out, different ways it could play out. Now how many games do we have? 1, 2, 3, 4 games in the first round. So we're at the quarterfinal round. And each one of those is 2. So we could say 2 to the 4th for the quarterfinal round. And maybe a better way for me to have said this is 2 squared for the semifinal round. And the final, there's 2 possibilities. So in total, now you get to check your exponent skills, but it's really counting. It's 2 to the 4 plus 2 plus 1, 2 to the 7. Okay, that's interesting. That's a pretty big number already. Okay, so that's how we count. In the NCAA tournament, there's a lot of games. Now, back when I was doing this, so in total, I'll put a few notes up here. Used to be there were just 64 teams. Now there's 68 teams. Because they have those first 4. I guess for a while there were 66 teams, but 68 teams. There's the first 4 games. After the first 4 games, what you end up with is 63 games. And that's an interesting separate question, which is, what am I getting when I add these numbers? 2 to the 1, 2 to the 4, 2 to the 8, and so forth. It's actually an example of something I've mentioned in other things. It's something you use when you're deriving the mortgage formula. It's that geometric sum yet again. And there are 6 rounds. I'm trying to think for a second. I think this is a 5. You have to check my arithmetic here. But then you have the first 4 games. So we're going to add the first 4 games. So there's a total of 67 games. So that's already a pretty darn big number. So in the actual, so first let's talk about counting. How many draws are there? So draws. It's going to be 2 to the 67. And that's a very large number, which I'll talk about in the next one. It's the total number of draws you can fill out. So there's our first counting tool, just multiplying, all right? So I'm going to put that over there. That's the number of draws. Now I want to talk about a different counting tool, sort of keeping track of the probabilities as we go. So let's go back to these first 4 games. Let's get rid of those college teams. What are they doing in here? Playing with the minions. Okay, let's say we have some odds. You know, if you have a 1 seed and a 2 seed, this is kind of the way. Normally it'd be seeds 1 through 4 set up in a certain way, but I'm pretending we're at a moment in the NCAA tournament where you have a couple 1 seeds, a couple 2 seeds, and you're down to the end. Actually, it'd be all 1 seeds if you were down to the end, if they all played to their level. But let's say you had a few odds, like we think that the Minions have a 70% chance of winning this game, or we have historical record that those seeds tend to win. And we have a historical record that the Hawks are going to win 60%. You know, they're a lower 1 seed. And sorry to the Pirates. I hope my wife's not mad at me that to make them lose. But we're going to pretend what happened. So we think there's a 7, instead of it being a 1 in 2 chance or a 50% chance as we were doing initially, we're going to make it a 70% chance. So this weights things differently, and that can be done. And I'm doing everything in a very simple way, but I just want to give people a taste for it. It's not magic where these calculations come from. Then lastly, let's say the Minions and the Hawks face off, and we think that's a 50-50 matchup. You can multiply those 3 numbers, and you get this 0.21. I already calculated earlier. If we'd have done the 50-50 flip a coin for each game, which is what usually when you see the stats posted for the NCAA tournament, the number they quote is the 50-50 number, which is sort of a bloated number, I would say. So this says the chances that you get a certain draw, if there's a 50-50 chance in every game, are about 12.5%. 12.5% chance that whatever draw you pick will be the right one if you randomly pick one and if all the games are completely random. But if you include the probabilistic piece, which is that we expect the higher seeds to win and we have certain probabilities, then we get something like, okay, we have a 21% chance that those seeds are going to make it through. And if you pick the seeds, you'd have more like a 21% chance that you have the right choice as opposed to a 12% chance. So I'm going to talk about both of those in just a moment when I start to talk about the probability piece. So I'm going to finish this by giving some numbers. That was really the tools we need, fairly simple tools from probability, is we're going to figure out the chances for each one. Okay, so what can we do then? And I'm no expert on this. I want to make sure I keep saying that. I'm just going to ask some questions that I hope students will take up. So you can look on the NCAA website, and they have all sorts of data. So this is from ncaa.com. And it says this is how the seeds do. And I'm sure you've heard some of these. 1 seed beats a 16 seed 987% of the 98.7% of the time. I was reading like a baseball stat. Well, that's another sport I have to talk about. So anyways, it shows a couple times there have been losses. So you can go back through the historical record and get these numbers. So you could, if you wanted to, get a better count, a better probability, is you could use this number in this slot when you're doing 116 games. And then you could use this number in the 215 slot, and you can do the probability a little more realistic. And people have done that. All right, so I'm going to show you the data I've collected on this. I didn't compute these, I fully admit, but using these same pieces. So we have the total number of draws is a really large number. Let's say a few things. Okay, so I have it prepared here, and I better make my fat head a little less fat. Okay, so here we go. Here's the data. So if you search online, this is what you see. I know this is kind of a clunky mess the way I have it, but production value is something I'm still working on. Assuming each game has a 50-50 chance, you get this number that gets quoted online a lot of 1 in 147.6 quintillion. And that sent me on kind of a long journey of what in the world is that and how do we make sense of it. And I think I'll make that in a separate video. It'll be less about the tournament, but might be of interest. It's this number. That's big, but I like, rather than just say big, I want to give you a little bit of numeracy. How can we think through that number? It's not that big in relative to other things we do in math. Bigger numbers come up. So I'm going to try to chew on that number in the next video. All right. But if you say the historical record is that when they look at the NCAA tournament, I just looked this up, that people tend to get about 2/3 of the games correct. That's over quite a few years. And this I'm pulling from the NCAA tournament. So if you assumed every game was about a 2/3 pick for the higher seed, the probability shrinks quite a bit. And you can do the calculation. Instead of raising 1/2 to the 67, which is basically what we're doing with the probability, and then we're flipping it to get a 1 in whatever, because it's easier to read it like that than as a long decimal. We can do the same thing, but we can use this. So you could play around with yourself. You could say, well, I always get it correct 80% of the time. Oh, then your chances are better. It's still an astronomical number, but a lot easier to chew on. So we'll talk about that. It's still just too big is the problem if you're trying to pick a perfect draw. Someone actually went through more precisely. Instead of doing, I found this online as well, instead of doing a 66%, they actually did the seeds. They used the data for each round, what was the higher seed, and used particular numbers. So that means in earlier rounds they had a lot more 90%. And that got the number down to about 46 billion. So these are reasonable assumptions that you pretty much can get it down to about 46 billion draws. If you pick from those 46 billions, there's a very good chance you'll have the winning draw. Okay. That's still a lot of draws. Anyways, I then looked, this is older data. I need someone to help me find the more recent data, but in 2019 was at the time, I think the video I watched was from a couple years ago, so it lasted a year or two. There was someone that had got 55 out of 63 correct, and that was the best ever. 8 people got it that year. The funny thing was that somebody had gotten the first 49 games correct, which is the most ever, and they didn't win. They ended up getting 54 correct. The story I watched actually said that somewhat more likely if you get a bunch correct at the beginning that you're not going to win because you had to pick really unusual teams to make that happen. Okay. So I find all that kind of just a starting place for counting. We're just doing a bunch of multiplying. It's not as big. We're not asking that complicated mathematical questions here. But Next thing I'd like to do is to get a sense of these numbers a little bit. That's less to do. That's going to be less exciting for the sports people. And then I'll dig through my old research, which I already have found quite a bit of it. And I'll talk about some practical things and try to funnel it down to a few types of draws if you had to pick some. And then lastly, I'll talk about my attempts to think of what would be a scheme to try to cheat if you had lots of draws. It's not really cheating, and how I failed, but how it might lead to some questions. All right, thanks for listening.